So we've been dealing with the concept of the roots of a polynomial and also the factors of the polynomial, the parentheses terms. We've been dealing with those for dozens of lessons by now, ever since we started talking about quadratics. Now we're going to formalize it and talk about the concept of the factor theorem. How do you know when something really is a factor of a polynomial? Also, if you have one factor of a polynomial, how do you find more factors? Because obviously factoring things is a really easy way to solve things, so we want to know how to find as many factors as possible. So first, let's write the factor theorem down, then we're going to explain it, talk about it, do some examples, and go from there. So we have this thing, again, one of the most important theorems in all of algebra, certainly. Theorem. Whoops, can't spell theorem. Right? And I have to write it down. Unfortunately, it's going to take a second. It's not super long, but I have to write it down because we have to talk about it. So we talk about the polynomial, p of x, that means the polynomial p of x, has the factor x minus c as a factor. Remember, these factors are little parentheses terms all multiplied together to give you p of x, right? So it has x minus c. C is a number. This means x minus 2, x plus 3, x minus 4, anything like that. It has this, whatever it is, as a factor if and only if, so it's a necessary and a sufficient condition, if and only if the number c is a root of the equation p of x, the polynomial, equal to 0. In other words, what this means is that the polynomial evaluated at c must be equal to 0. All right, this is a lot of words, and I know a lot of students look at words like this and then their brain freezes up and they don't even read the words because they look really scary. What this is saying is that if you know the roots of a polynomial, which we've been finding roots forever, we can get the roots from the quadratic formula, we can get the roots from completing the square, we can get the roots from factoring, right? But however you get them, if you know what the roots are, then you automatically know all of the factors of the equation. In other words, all those little parentheses terms, those are called the factors. They're all multiplied together to equal a polynomial. It's obviously very important for us to be able to find the factors of polynomials in order to be able to solve them. If you know the roots, in other words, if you know the values that make the polynomial go to 0, if c happens to be a root, meaning if it's a root, it means you stick it in the polynomial and it makes it equal 0, then x minus whatever values you have as those roots are all factors. All right, so that's really, really, really important because if you remember, we've been factoring these polynomials forever using all these different methods, and we even developed the completing the square and the quadratic formula to find all the roots to be able to solve these things. And along the way, we've been having to factor these things as well. So the factor theorem ties together what we've been doing before, but it formalizes it. So what I want to do is continue talking about this whole thing. Forget about these words for now. We're gonna bring it down with some concrete examples. So here's an example of what this factor theorem really says. Let's say you have a polynomial, and it's very concrete. It's x squared plus 4x plus 3. So we know we can try to factor this and set it equal to 0 and find the roots, right? And so if we're going to find the roots, that's exactly what we're going to do. Let's find these roots, the roots. How do we typically do it? Well, you can use the quadratic formula if you want, but we always try to factor this thing if we can. So we're going to say x squared plus 4x plus 3 equals 0. That's what it means to find the roots. You set the polynomial equal to 0. Then we do our little binomial thing that we always do. We have an x squared, so it's x times x. 3 can only be multiplied by 1 times 3 to give you 3. And then we have to have plus signs here. Inside gives you x, outside gives you 3x, they add to 4x. And so you know, we've been doing this enough that this is the factored form of this. So in this example, I'm going in a different direction to show you, in this case, we already know how to factor them. So when we say, what are the factors of this polynomial? What we're asking is, this is a factor and this is a factor. A factor, remember, just recalling from the past, a factor is just a fancy word that means, tell me the things that multiply together to give you that thing that you're looking at. So the factors of 12, there's lots of factors of 12, but 3 is a factor of 12 and 4 is a factor of 12. Why? Because 3 times 4 is 12. 1 is a factor of 12 and 12 is a factor of 12. Why? Because 1 times 12 is 12. 2 is a factor of 12, and 6 is a factor of 12. Why? Because 2 times 6 is 12. You see, factors are just the things that you can multiply together to give you the thing you're talking about. So this polynomial, we've already known how to factor it forever, and we now know that this is a factor and this is a factor. But what the factor theorem is telling you is going the other direction. The factors that you get are only factors if you find the roots of the polynomial, and then the factors are always going to be of the form x minus the whatever roots you have. So let's continue going down the road here. We know how to factor this, and we can then say that x plus 1 is equal to 0, so that one of the roots is equal to negative 1. And then we know that x plus 3 is equal to 0, so the other root is equal to negative 3. Okay? So what we know from doing these problems over and over again, we always told you factor it first, and then set this equal to 0, and then set this equal to 0, and those are going to give you the two roots, right? But more importantly than that, the factor theorem basically says that x is equal to, well, I shouldn't say the factor theorem, let me just go down here. We've found the roots. We know that x equals negative 1 is a root. Why? It's a root because if we stick it into the polynomial, you should get 0. That's the whole point. We solved them and we found them by factoring, okay? But if I just gave you, if I didn't do these middle steps, if I said this is a root and this is a root, how would you figure it out? You would stick it in here and see if it equals 0. That's what you would do. So you put the minus 1 in here and you get minus 1 quantity squared plus 4 times minus 1, and then plus the 3, right? And so what you get right here is a 1 minus 4 plus 3. You can see the 1 plus 3 is a 4, and then minus 4 is you get a 0. So we know that x is equal to 1 is a root. Yes, we did it by the way that we've learned in the past, but we also know that it's a root because when we put the number into the polynomial, it makes it equal 0. That's what the definition of a root is. All right? We know that x is equal to negative 3 is also a root, because when we stick that number into the equation, we also get 0. So negative 3 quantity squared plus 4 times negative 3 plus 3. What do we get? This is negative 3 squared, so that's a 9. And then minus 12 plus 3. And you can see that the 9 plus the 3 is 12, minus the 12, you get 0. So these are both roots. How do you know they're roots? Of course, we solved it the way we've always done. But the real way that you know you have these as roots is because these are the only two numbers that I can put into this equation and get 0 as an answer. They're the crossing points, if you were to graph this quadratic, where they cut into the x-axis, where y is equal to 0. All right? So the factor theorem is going a step beyond that. The factor theorem is telling you if you know the roots of the equation, you know the values of c, that make this thing, when you put them in there, equal to 0. In this case, the value of c is negative 1, and the other value of c is negative 3. You have those two values of c, then you automatically know the factors of this polynomial, x minus c, and then the other factor is also x minus c. Okay? So the factor theorem says, that simply because we know that x is equal to negative 1 is a root, then we know just because of that fact, without having factored it, without having knowing anything about it, that x minus a negative 1, or we say x plus 1, is a factor. Right? Because the form of it is, if you know what value of c makes the thing go to 0, then it's x minus that number. This number happened to be negative, so it's x minus that number, which means it's x plus that number. All right? And the factor theorem also says, in this case, because we know that a root is x is equal to negative 3 is a root, then x minus a negative 3, which means x plus 3, is a factor. All right? So the bottom line is, if I were to give you, if I never gave you the polynomial at all, if I never gave you the polynomial, if you didn't know that this polynomial had those roots, and I just said, there is a polynomial out there, it has a root of negative 1, it has a root of negative 3. Write down the polynomial. What would you do? The factor theorem tells you that since you know this is a root, that x minus that, which is this, is a factor. And then since you know this is a root, x minus that, which is this, is also a factor. And that because you know factors are things that just multiply together, then you know that the equation x plus 1, x plus 3, this is the polynomial that you seek. And when you multiply all this out, x times x is x squared, inside terms is x, outside terms is 3x, and last terms is 3. Then what you get is x squared plus 4x plus 3, which is exactly what we started with. You see, when we start learning algebra, we don't learn about the factor theorem. We teach you how to factor these trinomials and set them equal to 0 and find the roots. The factor theorem is telling you, I don't even care if you know how to factor anything. I don't care if I've never taught you anything about factoring. If you know the roots of a polynomial, you already know the factors. That's what it's saying. If you know the factor is -1, -3, I know that these are the factors just by the factor theorem. Factors are things that multiply together to give me whatever it is I'm studying. So if I multiply those factors together, this must be the polynomial in question, or at least one of the polynomials in question. We've talked in the past about how there could be a family of polynomials with these same roots. But this polynomial certainly does have those roots. All right, now I told you that there's two main things I wanted to really emphasize about the factor theorem. The first one was that if you know the roots, is exactly what we've been talking about. If you know the roots, then you know what the factors of that thing really are, right? That's the first thing. It's probably the most important thing. But another part of the factor theorem that we're going to do when we get to the problems a little more is that the other part of it is if you know only one of the roots, only one of the factors, then you can actually find more factors by doing division. Let me say that again. If I only give you one of the roots, so you know one of the factors, but you don't know the other one. Let's say I only give you that the root is this one. I never told you that -3 was a root, right? It's possible to take this information and by using long division, figure out what the other factor is, right? And that's not so obvious at first. And it's not even really written down in here, but it's really, really important. So before showing you how to do it with the algebra, I want to talk about numbers for a second, because it's going to make it way easier to understand. All right, if you remember back, you should remember that 3 times 4 is equal to 12, right? That's obvious, right? What 3 and 4 are, these are called factors. Factors are numbers that multiply together to give me what we care about. So factors of 12. Of course, there are more factors of 12. Like I said, 2 times 6, 1 times 12, 3 times 4, you know, that kind of thing. There's lots of factors. But it's perfectly fine to say that 3 and 4 are both factors because you can essentially, what it means to be a factor is you can divide it into 12 and get a whole number back. That's one way of looking at it. Another way is thinking that the factors can be multiplied together to give you 12. But the reverse way of thinking about it is factors are things that can be divided into 12 evenly. And what I mean by that is, think about what this means, that 3 times 4 is equal to 12. What it means is that if I take 12 and I divide it by 3, you already know that 12 divided by 3 is 4. Look at what happened here. If I only knew that 3 was a factor of 12 and I do this division, then I immediately figure out that 4 is also a factor of 12. Because again, 3 times 4 is 12, right? Also, if I only know, for instance, that 4 is a factor of 12, and I know that this divides and makes it 3, then I found the other factors. So this allows us to, I can find more factors. So, part 1 of the factor theorem is telling you about if you know what the root is, you know what the factors are. The other part is, even if you don't know all the factors, you can still use division to find the remaining factors. For the case of numbers, if I just told you, literally if I just said, hey, 3 is a factor of 12, find another factor. Then I would say, okay, well, what a factor is, I mean, you can think of it as multiplication, but in reverse is also true. Factors are the numbers that when I divide in, they give me a whole number of divisions with no decimals. So I divide it and I get a 4. So this must be a factor. And I try it and I divide it and I see that I get the 3 back. That's how multiplication works. 2 times 3 is 6. 3 times 2 is 6. 6 divided by 2 is 3. 6 divided by 3 is 2. You see how it all works out? So if I know only one of the factors, I can find the other one just by division. Now it's easy to understand with numbers, and I'm going to use that to make it easy to understand in algebra. Okay, so for instance, if I know the following, that this polynomial, p of x, is x squared plus 4x plus 3, and I know that it factors as x plus 1 and x plus 3. I know this why, because we just did it, right? I've shown you that when you multiply all this out, that's what you get. So this is the factored form of this. So what this means is, of course, you can kind of mentally cover this up. What it's telling you is this polynomial here is exactly equivalent to this factored form. They are the same thing. It's like they look different, obviously, but 1/2 is exactly the same thing as 5/10, which is exactly the same thing as 50/100. You get the idea? So they look different, but they're the same thing. So this is exactly the same thing as this. So what this means, because these things are exactly equivalent, this is an equation, right? I could take this, I could divide by the x minus plus 1 if I want. So what it's saying is if I take the x squared plus the 4x plus the 3, and I do long division, I divide by this, the x plus 1. I mean, remember, this is an equation. What it's saying is if I divide here, then I should get x plus 3 as an answer. Because I mean, you can see it's an equation. If I divide it, then this is what should be left. So let's divide it and see what happens. X times x is x squared. Do the multiplication. I'm going to get an x plus, I'm sorry, x squared here, plus x. I do a subtraction like this. All right, I do a subtraction. 4 minus 1x is going to give me 3x. All right? And then I drop my new number down, which is 3. Whoops. Make it a plus 3. And then x times what is 3x? I have to have a 3. So I multiply, get a 3x plus 3. Because I multiply this, I subtract. These both subtract to give me 0. There is no remainder. So factors are things that divide in and there's no remainder, right? Factors of 12 are numbers that divide into 12 with no remainder. 12 divided by 3 is 4, no remainder. 12 divided by 3 is 4, no remainder. 12 divided by 4 is 3, no remainder. 12 divided by 6 would be 2 with no remainder. 12 divided by 1 would be 12 with no remainder. Same sort of thing. They're all factors because you can divide them in and you get no remainder. So because you already know the factored form, in this example I'm using it to show you and prove to you that you can take polynomial. If you know one of the factors, you can divide it and get the other factor. So what this is telling you is that if I only knew that this was a factor, I could divide it in and I would get the other factor, x plus 3. So these are both factors. This is a factor because I knew that to begin with. And this is a factor which I just found by division. Okay? Let's go the other way and check it out and see what happens. If I take this polynomial again, where do I want to do it? Yeah, I'll do it right here. Let's do it right here. X squared plus 4x plus 3. Here I divided by x plus 1. Now we'll divide by x plus 3. We're going to divide this one and see what we get. We know that if we divide by x plus 3, we should get this thing back. So x times x gives me x squared. Multiply, I get x squared plus 3x. Subtract. 4 minus 3 is 1x. Drop the 3 down. X times 1 is x, and then plus 3. You can see, again, I get a 0 remainder. I should always get a 0 remainder back. So this thing was a factor because I knew it was a factor to begin with. And when I divided, I figured out that this was a factor. Extremely important for you to understand this concept because oftentimes a problem in algebra will go something like this. A polynomial, blah, 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 has a factor, x plus 1. Find the other factor. And you're going to be like, how do I do that? I have no idea how to do that. All you have to do is take the polynomial and divide by the factor that you know. The way that you can do that is you know that if it's a factor, it must be that these things are all multiplied together. So find the other factor is a simple matter of division, right? Just like we do with numbers, we could do the same thing with polynomials. We're going to do a lot of that in terms of the problem. So don't get too crazy worried about it yet because we're going to do it a lot. So, I'm not done talking about it. But for our last problem of this lesson, to kind of wrap it all up, I want to ask you the question. Is x plus 1 a factor of the polynomial x to the 7th power minus x to the 5th power plus x to the 3rd power minus x? So the question is x plus 1 a factor of this polynomial? Right? So half of the battle with this stuff is to figure out what it's saying. So what it's asking, it is asking the following. If we can write as the following. Basically, when it's a factor, what it's asking is the following true? Is p of x, this polynomial, can it be written as x plus 1 times some other function of x, some other junk here. In other words, if it's a factor, then it's going to be able to be multiplied by something else. So what the other factors are, I don't even know, but it's going to be able to multiply by other factors to give me this polynomial. That's what it's basically saying. When something is a factor, can it be written as a string of things multiplied together to give me what I'm asking for back? And the factor theorem tells us that the polynomial has this as a factor. If and only if this value of c, when it's x minus c, evaluates that p evaluated at c is equal to 0. In other words, it has to be a root. What has to be a root? Well, there's a number 1 in there, but the theorem is written as x minus c. So what we have to figure out is p of negative 1 equals question mark 0. Why negative 1? Because the theorem is written in terms of x minus the number, but the number was positive, so it was like x minus a minus 1, right? And so we have to evaluate it. Let me put it another way. If the question said, is x minus 1 a factor, then it's written exactly as the theorem says, and you would evaluate p of 1 because it's written as x minus 1. But the thing says x plus 1, so you have to flip the sign. So however you want to think about it works for me. We have to put it in there and figure out if it equals 0. So we're going to put the negative 1, raise it to the 7th power, negative 1 to the 5th power, negative 1 to the 3rd power, negative 1. Now, when you have an odd power, you're always on a negative guy, you're always going to get a negative answer. So this is negative 1 minus, this is an odd power, so this is a negative 1. This is a plus sign, this is an odd power, so it's a negative 1. And then this is a positive 1 because negative times negative is positive. Now we have double negative here, so we have negative 1 plus 1. This becomes a negative 1 plus 1. So this is 0, and this is 0. So what you get is 0 plus 0 is 0. So what you did is you looked at the factor, you picked the number 1 out. If it was x minus 1, you would have evaluated 1. But since it was x plus 1, you have to evaluate negative 1 because the theorem is written in terms of x minus whatever. And when you put it in there, you basically figure out that this is a root. So because it's negative 1 is a root of the equation, x plus 1 is a factor. If you were to have plugged in that value and gotten 3 or 2 or negative 1 or 17 or anything else, then it would not be a factor. All right, so we've done a lot in this lesson, and there's actually going to be 4, including this one, 4 different lessons on this. We're not done with the factor theorem. As I said, it's one of the most important theorems in algebra because it talks about solving polynomials, which is one of the most common types of equations that we encounter in all of science, in all of math, in all of physics and chemistry and engineering, right? So what it's basically saying is if you know the roots, the values that make this polynomial go to 0, then you automatically know the factors, right? If you know that 1 makes this thing go to 0, then x minus 1 is a factor. If you know that 5 makes this thing go to 0, then x minus 5 is a factor. If you know that negative 1 makes this thing go to 0, then x plus 1 is a factor, right? Because x minus a minus 1, it's got to be x plus 1 in that case. So if you know the roots, you know the factors. And secondarily, because what we talked about, the concept of what a factor is, that it's things multiplied together, if I only know one of the factors, I can divide and get the other one. So I showed with this here, for instance, we happen to know the factors here, but if I only gave you one of these one of these factors, I gave you the polynomial, I only gave you one factor and said, find the other one, then you would say, okay, I'm going to do division. Because that's what factors are. When you divide, you're going to get a remainder of 0 because it has to divide an even number of times, just like 3 divides into 12 an even number of times. You're always going to get a 0 remainder, and whatever's up here is the other factor. We did it both ways to show how that works. So now that you have an idea of what the factor theorem is, follow me on to the next lesson where we're going to crank through a bunch of problems. They're almost all going to center around giving you the roots, and then you tell me the factors. Or maybe I only give you one root, and then you have to divide, and you give me the other factors, and so on. So let's go ahead and start working the problems with the factor theorem right now. Learn anything at mathandscience.com.